Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the very first problem of the September Circuits 2021 of Hackerearth. The problem name is Zero Subarray. Okay, so before proceeding further to analyze this problem, I just want to associate the tags for this problem. It can be done with the help of it is going to be done with the help of two pointers and using the hash map you can also use, or you can use the multiset. And like in C++ I'm talking about, I don't know what is being used in Python. Yeah, but this problem is going to have the approach of two pointer. Like we need to find the maximum length of subarray of the given array A, right? So like the questions related to subarray, you are you need to think for the approach based on the hash map, or based on the two pointers, or in the worst case it's going to be like segment tree and all. Okay, so without wasting our time, let's understand this problem and we will be together building up the best solution for this problem. Okay, so let me first read it out the problem. If you haven't read it out, then I will recommend it to read it at least 2 times or 3 times. And if you are unaware about the logic of two pointers, or if you haven't used any concept of data structures like multiset or the hash map, then I will recommend go and visit and learn these topics and then come back to this problem, solve it, and if you are stuck upon, then go and watch this video again. Okay, so given an array A of n elements, and we can apply the given operations on the array A. So there are two types of operation. You can see type 1, choose an index I and set the AI exactly equal to AI minus 1. In other words, you are going to decrease the value of the current element by 1. And for the type 2, we are going to directly set the value of the current element AI as 0. And what we need to find out? We need to find out the maximum length of subarray in the array A, where all the elements in the subarray is going to be 0, by using at most x operations of the type 1 and y operations of the type 2. Okay, so we need to have the some limited boundary conditions, you can also say. We need to just find out the length of the maximum subarray. I hope you guys are aware about the concept of subarray. And we need to just find out the maximum length of subarray, and such that the all the elements in my current chosen subarray is going to be 0. If it is not 0, we are going to make it 0 by using at most x operations of the type 1. If you understand this statement like at most x operations, you need to understand the thing actually we are finding out the sum of the current element AI, because every time we are going to decrease the value of the current element by 1, so we need to just check it out. The like if we are saying that we are going to maximize the current length of subarray, and we are doing some, let's say, alpha operations of type 1, then let's say some elements of included in this type 1, then the sum of the elements that are included in this type 1 must be less than equal to x. If you're not going to understand this right now, no need to worry about. I'm going to explain with the help of examples also. First, let's move on to the basic understanding of this problem. Okay, and we have been given test cases and space separated integers array A, and for every test case we need to print the maximum length of subarray. Okay, so let's try to understand this problem with the help of examples and build up the best solution for this problem. Okay, so what we have been given in this problem is like we have been given some array of size n, and let's say the elements are like a0, a1, a2, a3, a4, and let's say up to a5. Okay, and we have been given two types of operation, type 1, type 2, and we are going to do this type 1 operation x times and type 2 operations y times. In type 1 operation, we are going to decrease my current element ai by 1, and in type 2 operation what we are going to do is we are going to say that if we are going to choose certain element and apply the type 2 operation, I will set ai is exactly equal to 0. Okay, and we need to find the maximum length of subarray, right? So what we need to understand this is consider the very first case. Like I am going to write down as case 1. Suppose y is greater than or equal to this length of the array n. If y is like greater than or equal to n, we need to just like we can set all the elements of this array as 0, right, by doing type 2 operations. Since there are y amount of type 2 operations being allowed and y is going to be like greater than or equal to n, we can set all the elements of the array A as 0. In this case, what is the maximum length of subarray? Our answer is going to be capital N, which is the length of the subarray. This is for the case 1, like when y is going to be like greater than or equal to n. Now consider the next case. Okay, so I'm going to talk about case 2. Y is going to be like strictly less than n. And we have the elements of the array as like A0, A1, A2, A3, A4, A5, let's say up to A6. Now, if y is going to be like less than n, what it means that if we start iterating from the left hand side of this array A, that is the left side of this array A, that is from index equal to 0, it means that first, let me just change the color first. First y elements, let's say y is up to 4. Okay, so I'm talking about y equal to 4 right now. Let's say y equal to 4. Okay, so first 4 elements of this array A starting from the left hand side can be included to our answer. Okay, like we can set all these elements as 0. Okay, like we have already used, like we have two type of operations, t1 t2, and this can be done y times, and if we are doing the t2 type of operation, we are going to set y elements from the current chosen subarray as 0. So if we choose first 4 elements of this subarray, you can see that all y amount, like all y is going to be utilized and all the elements are going to be set to 0. So this is the current valid subarray. But can we extend this valid subarray so that we need to maximize the length of the subarray being chosen? We need to just work upon the maximizing this subarray. Okay, and we all know that we have X amount of T1 operations can be done. Okay, now think upon a case like when we want to extend this right hand side of the current subarray, that is the interval L to R, to one more position, like including this A4 element. Okay, now this is going to be tricky point of this question. Now when we want to include this A4 element, you can see that there are 5 elements in my current subarray, and we can set only 4 elements of this subarray as 0. So what you are going to think that which 4 elements you are going to set as 0. So we need to we are having X amount of operations where for type 1 I am going to set AI exactly equal to AI minus 1, that is decrementing the current value of the element. So if we have been 5 elements and y is strictly less than the current length of the chosen subarray, you can say that I am going to make all the current maximum, like not saying it like that. I think let me just explain in some different words. Like okay, so we have the subarrays from L to R, and y is 4. Then we are going to make AI as 0 for the 4 elements that is lying in this subarray, and those 4 elements is going to be the maximum among all these elements. Like if you're not going to understand this, let's take this fact like 5 3 2 1 4. Okay, and like these are the elements, let's say, and if like this length of the subarray is like 5, and you can see that 5 is going to be like greater than 4, so it means that I am going to just make only 4 elements as 0. So the optimal case is like to make the first 4 maximum elements of the current subarray as 0, or you can also say in just general terms, if the current length of the chosen subarray is L, then you are going to say then you are going to just make L minus y elements to be included for type 1 operation, and y amount of elements, y maximum elements is going to be for type 2 operation. So what I will do is like 5 4 3 and 2 all are going to be set to 0. Why I'm going to do for the maximum elements, first y maximum elements of the current chosen subarray, because we need to include we need to include or we need to extend the current length of chosen subarray to more farther side, like we need to include r to the next position, we will try to include it that. We need to try to maximize the current length of subarray. Okay, that's why we need to just put out the first y elements of this current subarray, first y maximum elements as 0, and if we are left with the l minus y amount of small elements, and then we will check it out that whether this L minus y small elements, sum of these small elements is going to be like less than or equal to x, then the current then the current subarray is a valid subarray, and we can do that. Otherwise, we will try to increment our L pointer to the next position. This is basically a two-pointer approach. You can easily understand that. So the very important thing that needs to be understood in this problem is like, first pick out the y length of subarray and then try to include the next element to the right of the current index r. And if we try to include this r plus 1th element, then you are going to choose first y maximum elements and set it for type 2 operations, and the remaining element sum, L minus y element sum, if that sum is going to be at most x, then we are going to say yes, this is a valid subarray. Otherwise, we will increment L to its next position and check it out whether we can just compress this subarray such that sum becomes at most x. So let's try to understand this with this very small example. So let us take an array of 5 elements. So let me say 1, 2, 3, 4, 5, and let's say x is 3 and y is 2. Okay, so we are going to use the 2 pointer. Now the current pointer j is going to signifying this position index equal to 0, and I is also at this position. Let me write down j and let me write down I. Each time we will increment our I. Okay, now I is at this position. Okay, now you can see that y is 2, so we can easily include first y elements to our answer. Okay, so it means that I is right now over here, and our answer is going to be minimum, like our answer is going to be at least 2, it is obvious. Okay, now we will try to increment I to its next position. Okay, so let's say I is going to become, let's say I is going to be here at this position. Okay, so if I is over here at this position, you can see that I can set first y elements as 0, y maximum elements. Okay, so what I will do is like I will set all these two elements as 0, so it will become 0 and 0. Now here it becomes 1, and you can see that since x is equal to 3, first I will decrement it to 0, so it will become 0, and the remaining x that is going to be having, so x is remained as 2. You can see that these three elements, these three like length of subarray is 3, has the all the elements 0, so this is our current answer. So can we just extend this subarray to its next position? You can see that the element that is lying over here is 4. Okay, so if the element that is lying over here is 4, and you can see that my x is only remaining as 2, so I can decrement it to only 2. So still you can see that I have the length as 3, but this is not the optimal. Okay, so if you consider this case like your I becomes over here, and you have these 4 elements. As I've already said, each time you're going to pick up first y maximum element, so you will pick up 4 and 3 and make it 0, 0, 0, and here it is 5, and remaining sum is 3. You can see 2 plus 1 3, and x is also 3, so I will decrement 1 to 0 and 2 to 0 also. So you can see here it becomes the length of subarray as 4. Okay, and this is going to be like yes, maximum up to this point. Now we will try to increment our I to the next position up to here. Okay, so I will pick up first y elements. Note that j is up to index 0 right now. First y elements and make it y maximum elements and make it as 0. So it will become 0 and 0. Now you can see the remaining elements is having the sum as 6, and it is going to be like strictly greater than x. So this is not possible. I cannot extend our subarray up to this position. Okay, so what we are going to do is we will keep I here as it is, and we will try to increment our j pointer up to this position. So if I will do that, so I will be considering this subarray. So if I will consider this subarray, 4 and 5 will be set to 0 because these are y maximum elements of the current subarray, and the remaining sum is like 2 plus 3, it is 5 right now. So if it is 5, you can see still it is greater than x, strictly greater than x. So moving j to the next pointer, like to the next position, because we cannot have this subarray, so I will try to compress this current subarray. Now we are going to deal with 3, 4, 5. So you can see that I will first choose the y maximum elements and make it 0, and now this 3 remains. So what I will do is like you can see the sum 3 is going to be like at most x, so I can also set this as 0. So still my answer becomes maximum length of subarray up to this position is 3, but this is not the maximum because we have already got the maximum answer as 1, 2, 3, 4. Like for the subarray having the values 1, 2, 3, 4, that is from starting index 0 and ending index 3. So subarray having the maximum like set like we need to set all the elements of the current subarray as 0, and the maximum length of subarray is going to be 4. This has the length as 3, so this is not the maximum. So I think you have got the approach. What you are going to do, you need to choose every time y maximum elements, and remaining element sum should be at most x, and if it is not, try to increment your j pointer, or in other words compress your subarray. So let's head over to the coding section and analyze this problem in detail. Okay, so where is the thing? Yeah, so you can see all the test cases have been passed. Okay, so let's try to understand this. Okay, yes, what I have done is like for every test case I have taken the input. Let me just zoom it out. Okay, so I've taken the input nxy and there is an array, and first I've iterated and take the input of the array of I, like for every element, and if y is going to be strictly greater than or equal to n, maximum length of the subarray is the n, which is the length of the subarray, length of the array that is given. So I will just print it out, and like further statements is going to be stopped. Otherwise, if y is going to be strictly less than n, we can easily choose first y element. So I have initialized my answer as y, and the current sum as 0, and j is going to be also 0, which is the left boundary of the current chosen subarray. And I am going to keep track of the first small elements using the help of multiset, like what are the elements that is being included for the type 1 operation, and for like first y elements I am going to insert this in the multiset first. Okay, now starting from y, each time I will increment, like each time I will going to be insert this current element, newly included element into the multiset, and if like every time I am going to include that value which is going to be smallest, you can see sum plus equal to s dot begin, and this multiset is not having any comparator, so it will just sort the values in non-decreasing order, and I will do the two pointer approach. You can see if I minus j is going to be greater than or equal to y, because we are always going to choose the y elements, we can always do that. That's why I'm going to write down I minus j greater than or equal to y. And if that sum is going to keep track of the, like if the current chosen subarray is of l length, then l minus y sum is going to hold the value of l minus y. Okay, L minus Y smaller elements. First smaller elements, yes, right. So if that sum is going to be greater than X, then we will need to compress our subarray. So if that element is not present in this multiset, it means that that is being included into our sum. So we need to decrement it because I'm going to erase that entry also. That's why I'm going to check it out for that element, like array of j is not present in the multiset, right? And if it is present in this multiset, it means that that value is not included in the sum, so we will erase that entry from the multiset, you can see. Okay, and each time I also am going to increment my g. So if all these goes done, my current length of subarray is going to hold the, like it can be said that it is a valid subarray where I can set all the elements at 0 with the help of type 1 and type 2 operations. So I will maximize my answer with the current length of subarray, which is I minus j plus 1. And finally print the answer for every test case. Okay, so you will get the all test cases passed. So if you have any doubts, do let me know in the comment section of the video. And I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.